This video illustrates how to add Snubber Circuit to CD4047 based inverter circuit. It has explained why Snubber Circuit is required in inverters, high voltage spikes generated by transformer, and show how by adding RC Snubber Circuit the voltage spikes can be reduced to safe level. First, what is RC Snubber Circuit? An RC Snubber Circuit is a simple but critical protection network used to suppress high voltage spikes and ringing caused by the switching of inductive loads. It consists of a resistor and a capacitor, a C, connected in series, typically placed in parallel with a switching component like a MOSFET, or across the inductive load itself. First, I will show the high voltage spikes produced by the transformer switching at the MOSFET's drain. For this, I will place a voltage at the MOSFET drain. I will now plot the graph of the signal at the drain. As you've seen on the graph, there is voltage spikes on top of the actual square wave signal waveform. This spikes reaches up to 50 to 55 volts, which can damage the IFRZ44N MOSFETs. Next, I will place voltage probe at the two terminals of the output AC voltage. To plot the output AC signal, which is a differential signal VA VB, we add probe to the graph and configure the signal expression Vout is P1 minus P2. This is the 220 volt AC differential signal at the output of the inverter. As you see, there's no high voltage spikes. Now I will place the RC Snubber circuit across the drain and source of each MOSFETs. To calculate the resistor R and capacitor C values, I will use an online RC Snubber calculator. The link to this Snubber calculator is provided in the video description section below. Here I have used output power as 150 watt, the source battery voltage is 12 volt, the signal frequency is 50 Hz, the leakage inductance is 22 microhenry, and the DV, the high voltage tolerance, is 20 volts. The theoretical calculated value of resistor R is 1.6 ohm and capacitor C is 8.59 microfarad. Now we will use these theoretical values in our RC Snubber circuit. Here I am using the same RC Snubber circuit by copy-pasting to add Snubber circuit to the upper MOSFET drain to source. Now, let me resimulate the graph of drain signal. As you can see, the high voltage spikes are gone. That is reduced to manageable level from 55 volts to around 25 volts. To demonstrate the RC snubber circuit roll again, I will remove the snubber circuit connection and redo the simulation. As you can see, the high voltage appeared again. Now I will reconnect the snubber circuit. Resimulate the graph again. And as you can see, the spikes are gone. Now the MOSFET's power stage is safe from high EMF voltage from the transformer. Now I will simulate the inverter 220 volt AC differential output signal with the RC snubber circuit connected. I will again disconnect the snubber circuit to show the difference in the inverter output signal waveform when the snubber circuit is connected and disconnected. Why is it needed? In circuits like the inverter, components like transformers or motors act as inductors that store energy in a magnetic field. 1. The inductive kick. When a MOSFET, like your IRF-Z44N, switches off, the current through the inductor is suddenly interrupted. Since an inductor resists changes in current, it releases its stored energy as a massive voltage spike. V equals L times di by dt. 2. Protection. Without a snubber, this spike can exceed the MOSFET's breakdown voltage, leading to instant failure. That's it. The demonstration of RC snubber circuit roll in inverter circuit is complete. I hope you learned how the snubber circuit works. Thanks for watching. See you in the next.